4 billion years from now, the night sky will be ablaze with a sight no human eyes have ever witnessed. A massive spiral of stars will dominate the heavens, growing larger each night. Its trillion suns bearing down on our galaxy in a cosmic collision that will reshape everything we know. This is Andromeda, our nearest galactic neighbor, and it's headed straight for us at 110 kilometers per second. But this is just one act in a vast cosmic drama. Right now, you're sitting in a galaxy, the Milky Way. That's part of an intricate cosmic ballet involving over 80 galaxies, most of them dwarfs you've never heard of. These tiny galaxies are being devoured, stretched, and torn apart around us at this very moment. We live in a universe where galaxies are cannibals, and we're about to explore the most spectacular feeding frenzy in our cosmic neighborhood. Welcome to a journey across millions of light years, where we'll witness galactic collisions, discover ghost galaxies being consumed before our eyes, and preview the most spectacular cosmic event in our future, the merger of the Milky Way and Andromeda. I'm your guide to the local group, where giants and dwarfs dance in a gravitational choreography that's been playing out for billions of years. Our story begins with a mystery that plagued astronomers for centuries. In 964 CE, the Persian astronomer Abd al-Rahman al-Sufi described a nebulous smear in the constellation Andromeda. He called it Little Cloud, a name that vastly understated what would turn out to be a galaxy of 1 trillion stars. For nearly 1,000 years, this smear remained an enigma. Even after the invention of the telescope, astronomers couldn't agree on what it was. Some thought it was a cloud of gas within our own galaxy. Others suspected something more profound. The debate reached its climax on October 26, 1923, when Edwin Hubble, working at Mount Wilson Observatory, captured a photograph that would change everything. He had found a Cepheid variable star in Andromeda, a stellar lighthouse whose predictable pulsing allowed him to measure distance. His calculation was staggering. Andromeda was 900,000 light-years away, later refined to 2.5 million. It wasn't part of our galaxy at all. It was a galaxy. Hubble's colleague, Harlow Shapley, who had argued Andromeda was within the Milky Way, received Hubble's letter with the findings. He reportedly held it and muttered, "Here is the letter that has destroyed my universe, the Milky Way, our cosmic home imagine. In trying to map your own house while being locked in a closet. That's essentially our challenge in understanding the Milky Way. We're embedded within it, in 26,000 light-years from its center, in a minor spiral arm called the Orion Spur. Our galaxy spans 100,000 light-years and contains between 200 and 400 billion stars. Its spiral arms are stellar nurseries where new stars are born from vast clouds of hydrogen gas. At its heart lurks Sagittarius A, a supermassive black hole weighing 4 million times our sun's mass. But here's what makes the Milky Way special: its unusual stability. While many galaxies have experienced major mergers recently, our galaxy has remained relatively undisturbed for billions of years, allowing for the stable conditions necessary for life to evolve on Earth. Andromeda, the approaching giant Andromeda, also known as M31, is the Milky Way's big brother, or perhaps big sister. With 1 trillion stars to our 400 billion, it spans 220,000 light-years, more than twice our galaxy's diameter. On dark nights, it's the most distant object visible to the naked eye, appearing 6 times wider than the full moon, though much fainter. Recent discoveries have revealed Andromeda's violent past. Dr. Dougal Mackey from Australian National University found evidence that Andromeda devoured a massive galaxy, nearly half its size, about 2 billion years ago. The remnants of this cosmic meal are still visible as streams of stars orbiting Andromeda's core. While Andromeda and the Milky Way are the titans of our local group, they're outnumbered by a swarm of smaller galaxies, the dwarfs. These cosmic minions, containing anywhere from a few thousand to a few billion stars, tell stories of galactic evolution that the giants alone cannot. The Magellanic Clouds, southern sky jewels visible from the southern hemisphere. The large and small Magellanic Clouds are our most prominent dwarf companions. For decades, we thought they were loyal satellites, orbiting the Milky Way like cosmic pets. But recent measurements from the Gaia Space Telescope revealed something stunning. They're not orbiting us, they're on their first approach. Dr. Nitya Kalivayalil's team discovered these galaxies are moving far too fast to be captured satellites. They're visitors, perhaps on a one-time plunge through our neighborhood. Behind them trails the Magellanic Stream, a river of gas stretching across half our sky, invisible to our eyes but glowing brightly in radio wavelengths. Sagittarius Dwarf, death of a galaxy right now. On the opposite side of our galaxy's center, a drama of cosmic proportions is unfolding. The Sagittarius Dwarf elliptical galaxy is being torn apart by the Milky Way's gravity. Discovered only in 1994, despite being our closest galactic neighbor at 70,000 light-years. It was hidden behind the dense star fields of our galaxy's center. This dying galaxy has already orbited the Milky Way several times, each pass stripping away more of its stars. These stars form vast streams that wrap around our entire galaxy like ribbons. In fact, some astronomers believe our own sun might have originally formed in the Sagittarius Dwarf and was captured by the Milky Way billions of years ago. In the last 2 decades, astronomers have discovered a new class of galaxies so faint, they challenge our understanding of what a galaxy even is. These ultrafaint dwarfs contain only a few hundred to a few thousand stars, less than many star clusters within our own galaxy. Segway 1, discovered in 2006, is the current record holder for the faintest galaxy known. With only about 1,000 stars, it's 300,000 times less luminous than the Milky Way. Yet it's held together by a massive dark matter halo, making it one of the most dark, matter-dominated objects ever discovered. Dr. Marla Geha from Yale University, who studies these ghostly galaxies, explains, these ultra-faint dwarfs are fossils from the early universe. They're so small that after forming their first generation of stars 13 billion years ago, they never formed anymore. They're giving us a window into what the first galaxies looked like. Now we come to the main event, the future collision between the Milky Way and Andromeda. Using the Hubble Space Telescope, astronomers have measured Andromeda's sideways motion and confirmed what was long suspected. It's not going to miss us. The collision is inevitable. Here's how it will unfold. First approach, 3.9 billion years from now. Andromeda will dominate the night sky, appearing as a spectacular spiral larger than any current constellation. Earth's night side will be bathed in the light of 1 trillion alien stars. First pass, 4 billion years. The galaxies will slide past each other, their spiral arms stretching and deforming. Despite containing over 1 trillion stars combined, virtually no stars will actually collide. Space is that empty. But the gravitational disruption will be tremendous. The cosmic dance, 4 to 5 billion years. Like 2 dancers spinning around each other, the galaxies will orbit their common center of mass. Vast tidal tails of stars will be flung into intergalactic space, creating streamers hundreds of thousands of light-years long. Final merger, 6 billion years. Eventually, friction from gas clouds and gravitational interactions will cause the galaxies to merge completely, forming a giant elliptical galaxy. Astronomers have already named it Milkomeda or Milkomeda, if you prefer. Dr. Roland van der Marel, who led the Hubble observations, puts it in perspective. The Andromeda galaxy is heading straight for us, but residents of Earth don't need to worry. By the time the galaxies merge, our sun will have already swelled into a red giant, ending life on Earth as we know it. Here's the profound mystery underlying everything we've discussed. Most of what makes up these galaxies is invisible. The Milky Way's visible stars account for only about 15% of its total mass. The rest? Dark matter, mysterious, invisible stuff that reveals itself only through gravity. Dwarf galaxies have provided crucial evidence for dark matter's existence. The movements of stars in these small galaxies show they're embedded in massive, dark matter halos. Some ultrafaint dwarfs are 99.9% dark matter. They're essentially dark matter clumps, with a sprinkling of stars to make them visible. This raises profound questions. If dark matter dominates, could there be entirely dark galaxies with no stars at all? Some astronomers think they've found candidates. Mysterious clouds of hydrogen gas moving like galaxies, but containing no visible stars. Dr. Pavel Krupa from the University of Bonn challenges the dark matter paradigm. The distribution of dwarf galaxies around the Milky Way and Andromeda doesn't match dark matter predictions. They're arranged in thin planes rather than random spherical distributions. This could mean we need new physics. Our local group, this collection of the Milky Way, Andromeda, and their dwarf companions, is just one small neighborhood in a vast cosmic city. We're on the outskirts of the Virgo supercluster, which contains thousands of galaxies. And even that is just one node in the cosmic web, the largest structure in the universe. But here's something remarkable. Our local group is relatively isolated. The nearest similar group, centered on the galaxy NGC 5128, is 12 million light-years away. This isolation has allowed our galaxies to evolve without major outside interference, possibly contributing to the conditions necessary for life. Recent discoveries have revealed we're being pulled towards something called the Great Attractor, a gravitational anomaly hundreds of millions of light-years away. Our entire local group, along with thousands of other galaxies, is streaming toward this mysterious concentration of mass at 600 kilometers per second. What does our galactic neighborhood mean for the possibility of life? The interactions between galaxies might actually be crucial for life's development. When dwarf galaxies fall into the Milky Way, they can trigger bursts of star formation. The Sagittarius dwarf's repeated passages might have triggered the formation of our Sun's stellar nursery 4.6 billion years ago. In essence, we might owe our existence to a galactic collision. Dr. Mary Putman from Columbia University studies gas flows between galaxies. The Magellanic Stream and other gas clouds falling into the Milky Way provide fresh fuel for star formation. Without this cosmic recycling, our galaxy would have stopped forming new stars billions of years ago. But galactic interactions can also be destructive. When galaxies collide, the intense radiation from newly formed stars and active galactic nuclei can sterilize vast regions of space. The habitable zones in colliding galaxies might be limited to their outer edges. For all we've learned, fundamental mysteries remain. The missing satellites problem. Dark matter simulations predict the Milky Way should have thousands of dwarf galaxy satellites. We found fewer than 60. Where are the rest? Are they too faint to detect, or is something wrong with our understanding of dark matter? The planes of satellites. Dwarf galaxies around both the Milky Way and Andromeda are arranged in thin, rotating planes rather than random distributions. This completely unexpected organization challenges our models of galaxy formation. The local void. Our local group sits at the edge of a cosmic void, a region mysteriously empty of galaxies stretching 150 million light-years. Did something clear out this space, or did we just form in an unusual location? The fate of Triangulum, the Triangulum galaxy, M33, the local group's third spiral galaxy, might join the Milky Way-Andromeda collision, creating an even more spectacular triple merger. Or it might be ejected entirely, condemned to wander intergalactic space alone. As we end our journey through our galactic neighborhood, we're left with a profound realization. We are not residents of just Earth, or even just the Milky Way. We are citizens of a dynamic community of galaxies, all influencing each other in an intricate cosmic dance that has been choreographed by gravity over billions of years. Every atom in your body, except hydrogen, was forged in the heart of a star. Some of those stars might have originally belonged to dwarf galaxies devoured by the Milky Way eons ago. Others might have been born from gas stripped from the Magellanic Clouds. We are literally made of multiple galaxies, and our future, in 5 billion years, when the Milky Way and Andromeda finally merge, Earth, if it still exists, will have a view unlike anything we can imagine. A sky filled with the combined light of 2 trillion stars, with stellar nurseries blazing forth as new stars are born from the collision's chaos. But perhaps most humbling is this: our local group, with all its dozens of galaxies and trillions of stars, is just one of billions of such groups in the observable universe. Each has its own stories of collisions, mergers, and cosmic evolution. We've barely begun to explore our own cosmic neighborhood, yet it's already revealed wonders beyond imagination. The next time you look up at the night sky, remember, you're not just seeing stars. You're seeing galaxies devouring each other. Stellar streams stretching across the heavens. And in one faint smudge in Andromeda, 1 trillion suns racing toward us for a date with destiny. What mysteries do you think lurk in our galactic neighborhood? Could life exist in the dwarf galaxies around us? What will intelligent beings billions of years from now see when they look up at Milkomeda's sky? Share your thoughts and cosmic wonderings in the comments below. If you've enjoyed this journey through our local group, subscribe for more adventures through the cosmos. Until next time, remember, we're all made of galaxies, and our cosmic story is still being written.